Welcome, welcome. Come in, take a seat for our next talk here on the studio stage. You probably all know by now that the NeosCon app is the place to ask your questions so that I can relay them at the end of the talk to our speaker. And our speaker today is Dr. Andrea Herrmann. Thank you for the slide here. Freelance software engineering trainer, consultant, author. So a lot of practical experience as well as academic background. We've just had a little talk before the presentation. So I'm really looking forward to an interesting introduction, an overview of a lightweight requirements engineering for IT projects. And give a warm welcome to Andrea.
So, thank you for your interest in my presentation. Just a short presentation of myself. I have 30 years of work experience, and as you already heard, it's a mixture of academia and also practical work. I've been employed in IT companies for 7 years and was a bit frustrated by the chaos they have there. So I went back to academia to do research on software engineering. Also had some guest professorships, and now I'm a freelance trainer for 10 years already. So we start at the beginning. So what is requirements engineering? There are lots of definitions about this. I usually compare it to a translating job. That's how I felt it when I did it as a work. You have two different types of contact persons. On the one side, you have in the so-called problem space, you have users and customers, and sometimes they have no idea about technical topics, so they speak their banking language or whatever language they have in their usual day. And then you have a development team in the background, and they talk Java or ABAP or whatever. So they are technical persons, and the requirements engineer is the translator between these two worlds. So if the users say, oh, the prototype is nice, but we need this and that, then I go to the developers and translate it in their language. Like in this table, we need another attribute or whatever. And when the developers say something to me, I go to the customer and tell them in their language what this means. So the role who's doing that can also be a product owner or whoever, but you always have some sort of translation. And so this is also reflected in the definition of a requirement, because you have finally two different types of requirements. They all are called requirement, but some are in the problem space, so there you have a need that the stakeholders have. They should not say, sometimes they do, but they should not say, I need a button or something. They need something for their work, so they have work processes that must be supported by some technology. And then you have the technical experts, and the requirements in the solution space describe properties of the system, functionalities, and they talk of buttons or whatever. So even requirements are something that need to be translated from one language in the other. And that's something that I have observed in consultant projects often, that they mix up different things. So users talk of technology, and they write specifications which mix problem space and solution space, and that's already a bit dangerous. So requirements are the basis for everything else. So they describe what really needs to be done and also why it needs to be done. So it's the basis for effort estimation and also for contracts if you have a contract, and also time management. If you know how much time it takes, you can have a good expectation what you can do in 1 week. So finally, it should also be the basis, of course, of the code you write and of test cases and of user manuals, etc. So if you have really good requirements, then you have good basis for the rest, and you don't need to reinvent the system for testing or whatever. So that's the motivation for requirements. And there's a continuum between two extremes. One is the heavyweight requirements specification that you have usually in engineering area where you have security relevant systems like cars or planes. They need to specify everything in detail, usually on different levels of abstraction with a lot of information, and then also linking between the components and whatever, and problem space and solution space. How is the requirement of the customer implemented by a solution? So they need to do a lot of documentation. And in the lightweight area, you write only as much as needed because you also do a lot of communication, and that is sufficient because the requirements, they are not the documentation of the product. For example, when you build a plane, you need some documentation until the end of life of this plane. So that's needed because otherwise you're not allowed to fly this plane. But in other areas where it's not safety critical, you don't need such documentation. So it's rather requirements support the communication between the different participants of the team. So there you write as much as you need, and then you see spontaneously what you need. Maybe you say, I need a data model, then you draw a data model. If not, you won't draw a data model. So, and here a short look at heavyweight requirements. For example, in standards, you have a long list of potential chapters of such a specification and content that could be written down. And if you do this in practice, can really turn you mad because you have the impression that you have documented the same things 4 times, what is also the case because you write on several levels of abstraction, and you repeat yourself and you contradict yourself also. So that's really a lot of work. So usually we try to avoid this if you don't need to do it because it feels like a waste of time. In agile development, anyway, lightweight requirements are the norm. It's one of the principles of agile development, but there are also other situations in non-agile where you don't need too detailed requirements. For example, so-called delta requirements. That means you have a running system and then you implement some during maintenance some small changes, then you don't need so much detail. You have a team that knows the system well and you can work with lightweight requirements. And the same also when you do customizing of software. In my work experience, we usually had a standard software that was customized. So we did not specify completely from the beginning how the work process should look like because that was already a standard process in the system. So we only documented small changes or specific needs of the customers. And also the flexibility of the technology plays a role. If you have a flexible technology that you can modify easily, then it makes sense to start implementing early. Then you have a prototype to discuss with users, and then later on you can adapt it. So this very detailed upfront requirement specification is mainly needed when you have unflexible technology like hardware, or you build a ticket machine or something. Here you are not very flexible. And even if you will end up with a heavyweight specification, you might start with a lightweight one to just get an overview for the beginning. So now the good question is, how much do we need? That depends, so it's a quite complex question, how much will we need? But there's a good strategy to think about it. I took this from the IRAP foundation level. It's quite new in the version 3, and already applied this also with customers and found it very helpful to customize the requirements engineering process to the work processes they already have. There are lots of influencing factors. It's quite complex to customize the process to the specific team and project. And then there are some predefined facets that you look at, and you can do configuration of a process, and then in this order, work products and practices are chosen. So I will show you an example, a fictitious example. Let's take a zoo who wants to have a website. So when you have a digital agency, they will develop this website and they get a fixed price, so you need some definition of the scope. They have written a simple feature list, what features do they need, like selling tickets. And they have their standard development process with one prototype, and so they have the requirements engineering, make a first design and develop a prototype, and then show it to the customers, and then they discuss the details based on the prototype, and then they produce the final software. So it's not agile, it's waterfall, but with a prototype. So here the problem is that agile would not be possible because customers are not available for daily meetings and no on-site customer or whatever. Of course, they have no technical knowledge, so really you need both perspectives, the problem side and also the technical side. So you have no shared understanding. That's usually also helping when you have a team of developers and customers, key users who work together for years. Then also you can write simple requirements which have only some keywords in it and everyone knows what it is. But here in this case you have no joint understanding, so you need much more communication. And of course budget and time is tight, and the customers are not very certain about their requirements. So we have 3 types of facets which, according to the IRIP, are most influential on the perfect requirements engineering process. The one is the question, do you want to work in a linear fashion or iteratively? Because usually you have a work process, like in this example we have this 2-phase waterfall process, and some companies they say we only do waterfall, others do agile, so the requirements engineering process must adapt to what they do usually. So then the other question is, what is the purpose of the document? Is it sort of prescriptive document, like in automotive, for example? The supplier gets a specification of the component they need to deliver, and it's prescriptive, it's part of the contract. Or is it something working document where you work on, and it's exploratory in the sense that you jointly try to find out what the customer wants? So here in this case, it's rather exploratory. And then the type of development plays a role. It makes a difference whether you have one customer with whom you discuss all the time and you develop something that is for this customer, or whether you develop something for the market where you try to satisfy requirements of as many customers as possible. So if you draw this in a diagram, this is a 3-dimensional projected to 2 dimensions, so the purpose is perpendicular to the others. So you have here different places in the 3-dimensional room, but finally you will not combine everything with everything. So finally there are 3 main types of processes. You see here on the left side here, that's usually very heavyweight here. You have a contractual requirements engineering process where you have prescriptive requirements, a linear process, and everything is customer specific. For example, in automotive, you get specification and that's it. So this is a completely different situation than, for example, our SU website, where we have customer specific development of the website in a participatory process, because we have only some features and we need to find out together with the customer what they need, and we work in an iterative way. So this is our zoo website, and for example, development of the NEOS software as such is rather this product-oriented process where you develop a product for many customers. So here the difference is that it's market-oriented, but it's also exploratory and iterative. So these steps don't have time today. We will have a look at some of typical work products. According to IREP, for our zoo website, optimum is to have a backlog and to have user stories and prototypes and also a vision. So that's the recommendation. Finally, of course, it depends on the complete situation, but this is something best practice from the Agile. Here, a long list of work products that we have in Agile requirements engineering. You probably in Agile will not produce all of them, but they are all helpful if you need them. So for our zoo example, the question is, the question is, who uses the requirements for what purpose? So we do some requirements engineering for the requirements engineering process. So who are the stakeholders of the requirements? For whom do we write them and for which purpose? That's always a very important question because it depends all on the complete situation. So what we have is a contract with a fixed price, so we need some specification of project scope. So we know that they want to sell tickets. That's important information because this is complex functionality. So, and developers need to do some work planning. They need to know who can implement how many of the features and when will they do it. And you want to get user feedback in your prototyping iteration, so you need something to show them to get feedback. And in the end, we have acceptance tests before we can send out the facturation. So we need some acceptance tests in a fixed price project, and we need to know or should know in advance what are the acceptance tests. So how will they test this website? And say, this is what we wanted. So, and thinking backwards from that, we know what we need. Oops. Okay. What we need is also a vision because you have no shared understanding with the customers. So we need to get to know what the customers really want and what is the vision behind this website. Then we have this feature list, which is only a very short description what approximately they want, so no basis for the developers to know what they need to implement. So for the work planning, a backlog is good, and we can use user stories here and start early with developing a prototype to get feedback, and then we need acceptance criteria. So what could this look like? So vision can be described by a vision board. Here I was thinking over the simple, we want to present our zoo and sell tickets. There might be a larger vision behind, like protecting wildlife and doing education, things like that. So not only a target group is not only the visitor of the zoo, maybe the whole world. So, in the narrower sense, of course, visitors are the target group, so those who pay entrance, so we get money for them. Then we have needs. When they want to visit the zoo, they need to know when it is open and special events and things like that, prizes. And sometimes we have maybe fans of the zoo, so they get regular news. And maybe some sort of soap opera. Nowadays you have often some favorite animals there, and for example small animals which people like to watch growing. So like a soap opera, you get news every week. So a unique selling point from a customer perspective is that you have real world zoo and online information. So it's not only a format in the TV, they really can go there. And of course, for us business, we need money. We want to sell tickets more easily and get more, sell more tickets. And maybe have a base of volunteers who maybe do some advertising for the zoo or whatever. And brand building. So this is much more than only the functionality that is on a website. So the development team can understand how the zoo people are thinking and what is the objective behind what they do. That's really important, because if you only throw them some features over the wall, they can do it, but finally maybe it's not really fulfilling the vision. So backlog, you all know what a backlog looks like. It's a list of what needs to be done with priority or release planning or whatever. And this is, in the same time, it's requirement specification, but it's also a work plan. So this is very efficient if you can use the same documents for several purposes. Because otherwise, in the old world, you had requirement specification and a project plan, and when you change requirements, then you need to change also project plan. So you have sometimes you have too many requirements, so long lists, hundreds, thousands, or whatever. So it's a good idea to bundle them according to topics. And in Agile, you use, for example, features which describe on an abstract level what it's about. And then you have specific use cases, which are usage scenarios. So how do the user use the system to achieve a goal? And these use cases are implemented by tasks. So to get some structure into the requirements. So feature is in problem space. So it's something that the user sees and it's valuable for them. Like account management, so we have registered users and you need to manage the accounts. So not only they need to be able to create an account, but the users also want to change their email addresses or maybe even delete their account or something. And we want to sell tickets. And use case is this encryption of a scenario. So how is the user using this system? And usually you have, for each feature, you have several use cases. For example, if you manage accounts or whatever, you usually have create, modifying, deleting, and maybe even report about what accounts do we have. So we can use user stories to describe requirements. We can use them for features and for use cases and for whatever. It's just the form, it's not saying what it is. Here we say explicitly who is the person who wants to have it, what do they want, and what is the objective behind that. And as this is not very helpful as acceptance criteria, because this is still very general, we also need acceptance criteria additionally. Here also we have one-to-N relationships. So for each usage scenario, you need different test cases, so different acceptance criteria. Sometimes they are on a very detailed level, like this one here. When you are on this side and you want to do whatever, then you get this. So you break up the usage scenario in single steps. And then he is on the list of ticket options. Then he puts the ticket into the shopping cart, and here it's the moment where he can enter the number of children. This is also an art to design such processes in a way that it makes sense to the user. Such information like how many children do they have, this should not be entered too early or too late or forgotten or whatever. So there's also some thinking about work processes or usage processes behind. We can also use the good old use case template. That's from the times before Agile was invented, where you describe such scenarios stepwise. So here on the left, I have the steps of the user. On the right, what the system is doing. Usually, when I write requirements, I don't write a use case for every requirement that I have, because sometimes they are quite trivial. For example, when you want to have a report about something, then there are 2 or 3 steps, and then you have the report. So not very interesting to analyze this. But for usability questions, these descriptions are quite useful, because you think about in which order do we want to do things. Usually you also have some reference, like the previous system or other systems. You can look at the website of other zoos or maybe the cinema and look how do they sell tickets. But finally there are always variation possibilities. So we also have here preconditions, and somehow the postconditions have slipped again. Usually we describe preconditions, so we start here with the user who is already on the website, and postcondition is that the user can download the ticket as a PDF and also gets an email, and also we got payment. It's important from the side of the zoo. What I prefer to the textual presentation is also the graphical. So here an UML activity diagram with almost exactly the same content. Difference is that here we can present that we can do this in parallel. We can send out the ticket while the user is downloading the ticket from the website. And usually it's also easier in this graphical presentation to model error cases and repetitions. This is quite not so nice in a textual description. So these are some of typical work products that even in the lightweight requirements engineering I would model. So, but most important are always prototypes, because when you have users, they are not requirements engineering experts, so sometimes they even have problems to read such diagrams or to imagine the system. For them, it's only text or graphics, and they have no real idea what it might look like. So prototypes are helpful because they show already what the system will look like. So here in our development process, we said we have one single prototype. So not another prototype every week, only one. So, and we have different types of prototypes. Here the so-called wireframe is usually very primitive, can also be drawn by hand or something, and usually is used for an early stage where you still think about what information can we put on one side, and what will be the order or whatever, but colors or size of fonts also is not yet the topic. So this is just some thinking about what information do the users need for the visit. That's not so trivial. When you see the result, it looks like trivial, but in the process, you have a lot of thinking. So this is also helpful when you have not so flexible technologies, but also in early phase, first creativity workshop or something. So you don't put much effort in the preparation of the prototype because you just want to get a very rough idea. And then later on, you can develop a real native or evolutionary prototype. So evolutionary means you already use the technology for which you will also use for the final website. So it's already a real website, but it's in the prototype state in the sense that you will refine it later on. So here you can also discuss colors and sizes and the icons and so that's more realistic. So, okay, so I've got an impression how this can work. But as I said, there's still customizable. We have seen this long list of things that we can prepare in requirements engineering. Therefore, it's important that the requirements engineer knows all methods that exist and then spontaneously sees what they need for the communication. So anyway, requirements are important because they are the basis for everything. So it's not like we want to start coding and requirements engineering keeps us from working, but it's the basis of work. It's very frustrating if you program something and then you find out that the customer doesn't need it, he wants something completely else. So that's happens once and then you understand what requirements are good for. I know the problem in practice is that the customers, they find it difficult to agree on requirements. So there can be several iterations until they say, okay, this is what I want. But that's not the reason for not communicating with them. It's an art to communicate with them in a way that they understand what we want from them. So, but of course, we don't want to spend too much time in it. So, what is the minimum content of a specification? As I already showed, it depends. It depends completely on the situation, on the product, on the technology used, on how well do you know the business of the customer. So you need to do requirements engineering for the requirements engineering first and find out what you will need in the communication. So what is important is to think in problem space and also solution space and to keep them separate. So if you only think about technology and features in the system and the tables in the database, then you might maybe miss what the customer really needs. Like in our example, they want a zoo website, but finally they want to save the world and save animals, things like that. And you need to understand this business too. And prototypes are always useful. The requirements never were good enough to really understand the customer. And customer never understood completely what we have understood. So a prototype is something they can see and sometimes even touch and play with it. And then they can imagine whether this is what they want. And they start playing around with the usage scenarios and say, okay, I imagine I'm the customer. I want to book a family ticket for my family. How would I approach now? And then they say, okay, this looks like it can work. So this is more helpful because they are not requirements engineering experts, but they are experts for the zoo. No. Oops. Okay, thank you for your attention. And now I hope we get a lot of questions.
Thank you very much, Andrea. You can submit your questions through the app, so please do that. I already have a couple here. And the first question we have is, have you ever created a wireframe together with the customer because they know best how their business works?
These are two questions, or?
Yes, let's split them up. Have you ever created a wireframe together with the customer?
Not together. We talked with them, and then my student prepared a wireframe, and then we talked about it in a workshop.
Okay, and I think the second part of the questions relates to this translating between the customer knows how their business is supposed to work, and then you have to understand it good enough to actually create a wireframe. Yes. So have you ever managed to enable your customers to actually be part of that wireframe creation process?
That's difficult, yes. Because wireframe is already in the solution space finally. So what they contribute is a problem space. So they show me, for example, the legacy system, so old system they have been using so far, or templates they use, and so I get a feeling of their business, how they have been working so far. And wireframes are solution space, so I think it's natural if we prepare the wireframes and then ask for feedback.
Okay, thank you. Another question. How do you keep the documentation up to date? By coupling them to tests in Git, some sort of automation? What's your experience?
That's difficult, yes. We did not work agile, so we did not need to update so often. We worked on the requirements until we thought they are final. Of course, there were changes later on, refinements and change requests and things like that, but that was controlled without tools. So that's a challenge, because usually you don't have a one-to-one relationship between test cases and requirements and things like that, and they are not in the same tool, so you have often inconsistencies then.
Mm-hmm. Okay. We do have some time more for questions. Okay. Based on your experience, how well does estimation work based on the requirements you create?
Effort estimation.
Uh-huh.
For us, it was quite simple because we usually had a standard software, so we know from experience that one feature is 10,000 euro or something, or 10 days work or so. That was quite good. The problem was rather sales, because we said it costs so-and-so, and sales said it's too expensive. But the estimation itself was quite simple, because experienced programmers, they know exactly what it will take.
Okay, so building on that, do you use different requirements engineering approaches if you're developing a system from scratch, so greenfield, or if you're building on an existing system?
Yes, that's different, because, for example, when you use an SAP system, they already have standard processes, so you should better cling to these standard processes and not start with the empty UML diagram and start thinking about what could sales look like. So you start with what is already there, and if you really do something completely new, then you can be creative and think about different variants of how to selling something. So it's a large difference.
Okay. There's a question here. You showed the difference between lightweight and heavyweight requirements engineering. And lightweight seems so much simpler and faster. Can you go over the reasons again where you recommend heavyweight requirements engineering?
It's still the standard in, for example, automotive. There they need good concepts, and they also need to document everything. Why is there what? So they must do it to have a documentation. And later on, if something happens, they can prove that they have done good work. I think it's also easier for them because the next car looks a bit like the previous one, so they can reuse a lot. So if they have once a complete model of a car, they can reuse it and modify it. So if I have a new customer each time and we think of new systems, then there is not much reuse of requirements.
Okay. Does the size of the team involved change your requirements engineering process?
Which team? Development or customer?
Yes.
Not really. One could find arguments why it should, because if you have a small team, They are more like a core team who knows everything, so they don't need much documents. But finally, in practice, not everyone is there in every meeting, so of course they don't have full information, even if it's a small team. So you should write good requirements nevertheless. So I would say no, size of the team is not so important. The other factors are more important.
Okay, thank you. And the final question maybe, would you always go through the requirements engineering process with use cases and everything you showed us, even for small features like a new contact form for the website?
No. I already said the report is the typical example where you don't need a use case because you have input like search criteria and then you get output the report. So there it's more important to have an idea of format or look and feel and other questions than the use cases. So it really depends on the functionality.
All right, thank you very much, Andrea. Thank you for coming here and listening to her talk. Please don't forget to rate the talk in the NeosCon app so we can award the Best Speaker Award at the end of the conference. And next up on our schedule is the lunch break. But before we send you off there, we have our speaker thank you gifts for Andrea. The paper Neos N. And the custom-made Neos honey, so enjoy that.
Good.
And now, as I said, we have the lunch break and then the drone photo. That will probably happen on the grass down there. Maya said 1:30?
Yes.
I think so, yes. So if you want to be on the drone photo, please be down there at 1:30. And then I think talks resume at 2.
Yes, 2. And we have downstairs on the center stage a talk about 5 new things in CSS. And here, Markus with how Neos can save the planet.
So see you then. Thank you.
So see you later.